In this video, we're going to learn how to multiply rational functions. So yesterday we talked about what a rational function is, and we just said that it is a ratio or a fraction that has a polynomial in both the numerator and the denominator. So let's look at just basic fractions to see what we would do to multiply these. And if you remember from a few years back, in order to multiply fractions, you just multiply the numerators. So 5 times 4 is 20. And then you multiply your denominators. 7 times 1, or 7 times 3 is 21. And then you see, can you reduce the fraction? Are there any numbers that divide evenly into both your numerator and denominator? In this case, there aren't. So this is as simplified as it gets, 20 over 21. So now let's apply that to rational functions. So I got x plus 2 over x squared plus 0x minus 16 times x plus 4 over x squared plus 8x plus 12. So let's break this down bit by bit. So let's look at the left-hand side. X plus 2, there's nothing to factor here. These two terms don't have anything in common, so it's just going to stay x plus 2. In the denominator, I can factor that. So I'm looking for two numbers that multiply to negative 16 and add to 0, which are negative 4 and positive 4. So let's rewrite this fraction. X plus 2 in the numerator stays the same. And in the denominator, we now have x minus 4 times x plus 4. So let's go over and do the same thing to the fraction on the right. So x plus 4 cannot be simplified, so that's going to stay the same. The denominator, I need two numbers that multiply to 12 and add to 8, which are 6 and 2. So the denominator factors to x plus 6 times x plus 2. So we just said on the previous slide that in order to multiply fractions, we just multiply across the numerator and across the denominators. So we're going to do that here. So I've got x plus 2 times x plus 4, and I'm just going to leave them in factored form like this. I'm just going to write them in parentheses side by side, and then I'm going to multiply my denominators together. So I've just got 4 sets of binomials here, and I'm just going to write them right next to each other because they're all being multiplied together. All right, so there I've multiplied everything together, but yesterday we learned how to simplify. So all we're doing here to simplify is looking for what's the same that can cancel in the numerator that's in the denominator that can cancel each other out. So in the numerator here, I've got x plus 2, and I've got an x plus 2 in the denominator. So those are going to cancel each other out. I also have an x plus 4 in the numerator and an x plus 4 in the denominator. So those are going to cancel each other out. You'll notice here that everything in the numerator canceled out, and we talked about this yesterday. There's still a 1 here. So if everything in your numerator cancels, you need to make sure you leave a 1 there. So 1 divided by x minus 4 times x plus 6. And I can take this a step further, and I can take this denominator and I can put it back into standard form. So multiply it out using the box method. And when you do that, you get x to the second plus 2x minus 24. So this is your final simplified version. So pause the video, try the next 3 examples, and then start up the video again to check your work. All right, next example. We've got 6 over x squared minus 3x times x minus 3 over x. So take it fraction by fraction. Let's look at the left. The 6, I can't factor that. That's just going to stay 6. The x to the squared minus 3x, I can take an x out of both of those because they both have x in them. So when I factor that, that x that I'm factoring out of both of them is going to be written on the outside of my parentheses, and on the inside, I have x minus 3 left. Let's look at the fraction on the right. X minus 3 in the numerator, that can't be factored, so that stays as is, and the x can't be factored, so that stays as is. So let's go ahead and multiply these together. So take your numerators, the 6 times x minus 3. So they're being multiplied, and the denominator, I've got x times x minus 3 times another x. So let's go ahead and start canceling things out here. In the numerator, I have x minus 3, and I also have x minus 3 in the denominator, so those cancel. I'm left with 6 in the numerator, and I'm left with x times x, which is x to the second power. So that is your final answer. Next example, I've got lots of binomials here, so I want to make sure that I can factor something out, a greatest common factor from each of them, and then simplify. So let's start on the left. 5x plus 15, I can divide both of these by 5. So when I do that, when I factor that 5 out, that 5 gets written on the outside of the parentheses, and what's remaining goes on the inside. So 5x plus 15 factors to 5 times the quantity x plus 3. In the denominator, the 8x minus 32, I can factor out an 8. So that goes on the outside, and you're left with x minus 4 on the inside. Let's look at the other fraction. 7x minus 28, I can take a 7 out of both of these. So that gives me 7 times x minus 4. And 2x plus 6, I can take a 2 out of both of these. So that leaves me with x plus 3. So let's go ahead and multiply these out. So I have this 5 on the left times 7, and I'm just going to go ahead and multiply those. 7 times 5 is 35. Then I've got the two binomials, x plus 3 times x minus 4. In the denominator, I've got 8 times 2, which is 16. Then I've got x minus 4 times x plus 3. So now let's cancel out what is the same in the numerator and the denominator. X plus 3, those are gone. X minus 4, x minus 4. The only thing left is 35 over 16, and that's your final answer. All right, last example here. Let's go ahead and factor. 4x, that can't be factored, so that's just going to stay 4x, divided by, I can factor this trinomial, two numbers that multiply to positive 1 and add to negative 2 are negative 1 and negative 1. So this is going to factor to x minus 1 times x minus 1. Over on the right, I've got x minus 1 in the top, which doesn't factor. And in the bottom, I can take a 4 and an x out of both of these. So 4x, and I'm left with x minus 3. All right, so let's start and rewrite these all. So 4x times x minus 1 all over, got x minus 1 times x minus 1 times 4x times x minus 3. And let's cancel some things out. So this 4x that's in the top here, that'll cancel with that 4x. This x minus 1 only cancels with one of these x minus 1s. I know there's two here, but if you're only canceling one from the top, you can only cancel one from the bottom. So this other one has to stay put. Remember, if everything in your numerator cancels out, there's still a 1 there. So here we're going to have 1 over x minus 1 times x minus 3, and you can multiply that out. So you have standard form. So we'll have x to the second minus 4x plus 3, and that is your final answer.